Sawadee-ka. Hi, I'm Sean. Now we are going to discuss Edexcel International Advanced Level, paper reference WME02/01, Mathematics, International Advanced Level, Mechanic M2. Before we start our discussions, please remember to hit the subscribe button. Thank you very much. Now we start from question 1. At time t second t bigger or equals to 0, a particle P has a position vector r meters with respect to a fixed point origin O, where it's given like this. So we are asked to find the acceleration P when t equals to 4. Okay, so now, position vector means the displacement. So here we have this r. T power 3 minus 8t. 1 over 3 t power 3 minus t squared plus 2t. Okay, let's find the velocity, differentiate with respect to t. So velocity is equals to, so for this one, 3t squared minus 8 t power 2 minus 2t plus 2. Okay, then accelerations. So here differentiate with respect to t, so I have 6t. So 2t minus 2. So here is our accelerations. So what the questions want to find here is the accelerations when t is equals to 4. So when t equals to 4, acceleration is 6 times 4, 2 times 4 minus 2. So which is equals to 24. So 2, 4, 8, 8 minus 2 is 6. So which means the accelerations 24i plus 6j. So this is for part A, to find the acceleration of point P, particle P. So now for B, at time t second where t is bigger or equals to 0, P is moving in the directions 2i plus j. So we are asked to find the value of t. Now, the keyword here, moving. So moving means velocity. So the directions of the velocity is parallel to the directions 2i plus j. So which means, so for B here, so the velocity parallel to the directions 2, 1. So this one, V is 3t squared minus 8, and then t squared minus 2t plus 2 is equals to lambda 2, 1. Okay, so here, just do comparing. So 3t squared minus 8 is lambda times 2. So here I have this 3t squared minus 8 equals to 2 lambda. And then compare the vertical component. T squared minus 2t plus 2 is lambda times 1. So here we have this t squared minus 2t plus 2 is equals to lambda. So here is the first equation, second equation. So both of these we have this lambda. So which means I will take first equations, substitute into second equation, substitute into the first equation, sorry. So which means t squared minus 2t plus 2 is equals to, so 3t squared, minus 8 equals to 2 lambda. So t squared minus 2t plus 2. Okay, so solve these equations. So I bring everything over to the left side. So 2t squared, 2 times t squared, 2t squared, bring to the left become minus 2t squared. So 3t squared minus 2t squared, I will get t squared. 2 times negative 2t is negative 4t. Bring to the left become plus 4t. So here plus 4t. 2 times 2 plus 4. Bring over to the left become minus 4. So minus 8 minus 4 is minus 12 equals 0. So here we form a quadratic equations. So factorize and find the value of t. So for this one, 12, 6, 2. So t plus 6, t minus 2 equals to 0. So here we have this t equals to negative 6 or t equals to 2. So t cannot be a negative number. So therefore, answer to the questions. So the value of t. So which means, therefore, t is equals to 2. So here is the first question. And now we proceed to second questions. So here we are given a diagram. So the point A lies on a smooth horizontal floor between two fixed smooth parallel vertical wall, WX, YZ, as shown in the diagram. So this is a ball, and then this is the wall, and then this is a horizontal plane. So now, the distance between WX and YZ is 3D. So the distance here is 3D. Okay, and then the distance A from YZ is D. The particle is projected from point A along the floor with the speed u. So from here, we project u towards the YZ directions and perpendicular to YZ. The coefficients of restitutions between the particle and each wall is 2 over 3. So this one means when the particle hit the wall and rebound back is 2 over 3 of the initial speed. Now, the time taken for the particle move from A, bounce off each wall once and return to A for the first time is t1. So it means the particle from here, move over here, and then after that, move to the wall, xw, and then move back to point A. The time taken is t1. Now, for part A, we are asked to find t1 in terms of d and u. So how are we going to do this? So for part A, so now let's see from here to here. So the speed is u. So what is the time taken? So from A to YZ. So the speed is u, and then the distance is d. So the time taken. So just simply distance divided by speed to get the time. So which means is d over u. Now, when the particle bounces back, so the coefficients here is 2 over 3. So which means from YZ to WX, so from YZ to WX, so what is the speed now? The speed is u times 2 over 3. So which is 2/3u. Okay, then the distance. So YZ to WX. So from here to here is 3D. So which means the time taken is equals to same thing. I will use distance divided by the speed. So which is it's easier to so the time. So 3D divided by 2/3. So for this one is 9/2 d/u. Okay, now then after that, from this wall, we go back to this point A. So from WX to A, so now what is the speed? So when the particle moving to here, the speed is 2/3u. So when it bounce back, so this one need to multiply with 2/3 because of the coefficients given here. So which means 2/3u multiplied with 2/3. So here we have this 4/9u. Now what is the distance? So from WX to point A, so whole thing is 3D and here is D, so therefore here is 2D. So which means the distance is 2D. So what's the time taken? So same thing, I will use distance divided by speed. So 2D divided by 4/9u. So which is 9/2 d/u. Sorry. Okay, so for this, you can always verify by using calculator. 2 divided by 4/9. So it's 9/2. Okay, so now the total time taken is the T1. So therefore, T1 is equals to, so from here, here, and here. So I just add all these values. So d/u plus 9/2 d/u plus 9/2 d/u. So which is equals to, so for this one, 1 plus 9/2 plus 9/2. So here we have 10. So the answer for the first one is 10 d/u. T1. Second. So this is for part A. Okay, so now for part B. So let me copy this whole thing here. So for B, basically we are asked to find the ball returned to A for the first time after bouncing off each wall once. So the further time taken for the particle to move from A, bounce off from each wall once, and return to A is T2. So which means, so at these positions for the second time, come to here, and then come to here, and then go back to point A. So the time taken here is T2. Okay, so near here, It's the same process, it's just different values for the speed. So same thing from A to YZ. So the speed is, so what is the speed? The speed is here, 409U. So which means 409U. And then need to multiply with, no need. So for this one, it's just 409U. Okay, then the distance is D. So for the time taken here, so same thing, I take distance divided by the speed. So which means D divided by 409U. So which is 904 D over U. Okay, then next, from YZ to WX. So the speed, so 409U. So which means when the particle comes to here, is 409U. So when it bounces back, so we take this speed times 2 over 3. So here, 409U times 2 over 3. So here we have this 8 over 27 U. Now what is the distance? So the distance from YZ to WX is 3D. So what is the time taken? So the time taken, I take distance divided by the speed. So 8 over 27U. So which is equals to 81 over 8 D over U. Okay, then next. So same process, different values. So from WX, go back to point A. So the speed. So the initial speed now is 8 over 27U. So which means 8 over 27U. Then multiply with 2 over 3. So here I have this 16 over 81 U. Then the distance is 2D. So what is the time taken? So distance divided by the speed, 16 over 81 U. So for this one, so you can verify by using calculator if you are not very certain. 2 divided by 16 over 81. 2 divided by 16 over 81. So it's 81 over 8 also. So 81 over 8 D over U. So now the total time taken T2 for the whole process. So I just need to take this one plus this one and then plus with this. So which means here I have this 904 D over U plus 81 over 8 D over U and then plus 81 over 8 D over U. So all they are D over U, D over U, D over U. So I just need to add all the coefficients. So 904 plus 81 over 8 plus 81 over 8. So 45 over 2 D over U. So this is for part B. So let me refresh, go to the questions again. The solutions. Okay, so now let's proceed to question 3. So a particle P of mass 0.5 kg is moving. So 5 kg, 0.5 kg is moving with the velocity lambda I plus j and s negative 1. Then P received an impulse of magnitude square root of 5 over 2 Newton second. So immediately after P received the impulse, the velocity P now is 4 pi. So given that lambda is a constant, so find the two possible values of lambda. So now how are we going to solve these questions here? So for this one is the initial velocity, and then for this one is the later. So after impulse. So what is impulse? Impulse is the change of the momentum. So let's see what is the changes in momentum. So that's right, the initial velocity, lambda, 1, so which is equals to lambda, lambda. Then the velocity after the impulse, 4I, so which means 4, 0. So the changes in momentum, so the impulse. So we take the later minus the initial. So MD, so M is 0.5, so which is 0.5 times 40, and then minus 0.5 times lambda lambda. So which means the impulse. So 0.5 times 4 is 2, so 2 minus 0.5 lambda, and then 0 minus negative 0 minus 0.5 lambda, so here we have the impulse. Now, we are told that the magnitude of the impulse is square root of 5 over 2, so which means the magnitude square root of 5 over 2, so which means square root of 2 minus 0.5 square plus negative 0.5 lambda square is equals to square root of 5 over 2. So for this one, I just square both sides. So here I do the expansions for this. So here I have 4, and then 2 times 2 times negative 0.5 lambda. So for this one, 2 times this, I will get negative 1, so which is negative 2. So here is negative 2 lambda, and then plus 0.5 lambda square, so which is 0.25 lambda square. So plus 0.25 lambda square, and then plus for this 0.5 lambda square, so this one is 0.25 lambda square equals to square root square, so it will cancel off, so I just left to 5 over 2, which is 2.5. So I just rearrange it, so which means 0.25 lambda square plus 0.25 lambda square, I get 0.5 lambda square, and then minus 2 lambda. So 2.5 bring to the left become minus 2.5. So 4 minus 2.5 is equals to 1.5. So plus 1.5 equals to 0. So for this one, I will just multiply the whole thing, or you can use quadratic formula to find lambda directly. So for this one, I just multiply everything by 2. So here I have this lambda square minus 4 lambda plus 3 equals to 0. So which means lambda minus 1, lambda minus 3 equals to 0, factorize. So here lambda equals to 1, or lambda equals to negative 3, sorry. So here I have two answers for the lambda. So this is question 3. Okay, now proceed to next questions. Question 4. A truck mass 900 kg is moving along a straight horizontal road with the engine of the truck working at a constant rate of p watts. The resistance to the motions of the truck is modeled as a constant force, magnitude R Newton. Okay, so next, at the instant when the speed of the truck is 15 ms-1, the deceleration of the truck is 0.2 ms-2. Okay, now next. Later, the same truck is moving down a straight road inclined at an angle theta to be the horizontal, where the sine theta is 1/30. The resistance to the motion of the truck is again modeled as a constant force of a magnitude R Newton. The engine of the truck is again working at a constant rate P watts. So basically the two situations, all the variable, they are the same. So it's just that one is horizontal movement, another one is going down. So at the instant where the speed of the truck is 12 ms-1, the acceleration of the truck is 0.4 ms-2. So we are asked to find the value of R. Okay, so now let's look at these questions here. So what am I going to do is I will try to draw the two situations. So for the first situation is horizontal. Then after that, incline. Okay, so we have the truck here. Okay, so for this one is 900 kilogram. So let's look at this. We have the gravity, mg. So for this one is 900 gram. 900 g. And for this one, same thing. We have 900 gravity. Okay, and then for this case, the angle here is theta, where we are told that sine theta is 1/30. So here we have this sine theta is 1/30. So for this one, let's draw this diagram here. So we are told that sine of this angle is 1/30. So which means 1/30. Okay, and then how about the adjacent side? So just use Pythagoras theorem. So 30 square minus 1 square. So it's 899. So for this one is square root of 899. So which means the cosine of the angle is square root of 899 over 30. Okay, so this is the information that we have about the angle. Okay, so now let's look at this one. So which means here we have, so for this, because this is theta, and then the draw derive the mg into these two directions. So this one is theta means this is theta. So this one is cosine. So which means 900 gravity cosine theta. So for this one is 900 cosine theta. And then this one will be 900 gravity sine theta. So this one is R, sorry. So I'll draw this, sorry. Okay. So this one is 900 g cosine theta. Okay, now let's see if there's other forces that we have here. So we have R. So for this one, we have these directions. Okay, and then what else? We also have, okay, for these questions here, it seems that these directions is not very important because we already given the force. So the resistance force is here. So maybe just erase this first. So the resistance force here, because the particle is moving to the right side. So for this one, the resistance is these directions, R constant. So the resistance, magnitude R Newton. So for this one, the resistance R newtons. Okay, and then we have the power. So which means this is from the power. Okay, then what else? So the other information that we have here is the particle. For this case here is the speed is 15 and the acceleration is 0.2. So when the particle is moving in these directions, so the v is 15 and then the a is equals to deceleration. Be careful of the words here. So a is negative 0.2 and as negative 2. Okay, then when we're going downwards, speed is 12, accelerations is 0.4. So which means for this direction here, so the v is 12 and s negative 1, and then the a is equals to 0.4 and s negative 2. So here I have roughly put in all the informations, and then the engine working at a constant rate. So the power of the engine is P watts. So here I have all the informations drawn in the diagram. Okay, so now for the power, we know that power is F times V, the force multiplied with the speed. So which means P over V. So the engine, the force here is P over V. So the force here is P over V. Okay, so now look at these two positions. So I will call this one as positions 1 or case 1. And then this one I call it as case 2. So first case, second case. So look at case by case. So if for the case 1, the first case here. Okay, so now let's look at this. We have a force that pulling the object in these directions, that is P over V, and then the resistance is R. Okay, and the acceleration is negative, so we just assume that it's positive. The object is moving to the right side, so which means for this one, NA, the resultant force, so N is 900, okay, and then the A is negative 0.2 equals to P over V. So P over V. Where's the V here? So the V here is 15. So which means P over 15. Okay, then minus the resistance R. So here I form an equations. So I try to make R as a subject, or P is a subject, so never mind later on. So look at case 2, because we know that we need to solve simultaneous equations here. So for the second case here, so N is this, the A is 0.4. So which means the resultant force, 900. The A is 0.4 equals to. So now in these directions, beside the power, and we also have the gravity, so which means P over V. So now what is the V here? The V in the second case is 12, so P over 12, and then plus with the gravity, so 900, gravity sine of the angle, and then we have to minus the resistance. So which means for this one, I just simplify the numbers. So I form two equations here. So for the first equations, we have 900 times 0.2. So 900 times 0.2. So here I have 180. So negative 180 equals to P over 15 minus R. So here, if I want to find R, so the persons want to find R, so I just make P as a subject. So which means R minus 180 is equals to P over 15. So 15 times R minus 180 is equals to P. So here I have this 15R minus, so 15 times 180, 2700 equals to P. So here I have the first equations. Now look at the second case here. So the first one here, we have this 900 times 0.4. So 900 times 0.4, so 360 P over 12 plus, okay, gravity 900 times, gravity is 9.8, and then times sine of the angle. So what is the sine of the angle? So the sine is 1 over 30, so times 1 over 30. So which is equals to 294. So here I have 294 minus R. So I try to make P as a subject. So 294 bring over here become minus. So 360 minus 294. So what do we get? So 360 minus 294 is 66. So here I have 66 plus R is P over 12. So 12 times 66 plus R is equals to P. So 12 times 66, 792 plus 12R equals to P. So here I have my first equations, second equations. So both of these, they are R here, they are P. So which means this and this, they must be equal. So therefore, 15R minus 2700 equals to 792 plus 12R. So which means 3R is equals to 2700 plus 792. So here I have 3492. So the R is equals to, divide by 3 here, 1164. So for these questions, there are a lot of informations. So always is good to draw the diagram and put all the informations in the diagram. So this is what we have for question 4. Okay, so now next. Question 5. Okay, a uniform rope AB has length 4 meter, weight 50 Newton. So for this one, the rope, so we assume that the middle is the center of mass. So for this one, 50 Newton. So this is the first informations. Okay, the rope has its end A on the rough horizontal ground, A on the ground, and then the rope is held an angle alpha degree and alpha angle to the ground by a cable attached at the B, shown in the diagram. So the cable and the rod lie at the same vertical plane. The cable is perpendicular to the rod. So this one is perpendicular to the rod. So the tension is T Newton. So it's given here, T Newton. So sine alpha is 3 over 5. So always be given these informations. So what does it mean here? So it means that for this alpha, so this is alpha. So we are told that sine alpha is 3 over 5. So which means 3 here, 5 here. Pythagoras theorem, so here we found that is 4. So which means cosine alpha is 4 over 5. So I just prepare this in case we are going to use it later. Wait, part A, we are asked to show that P is equals to 20. Okay, so now, how are we going to do for the first part? So for this one, is 3 dimensions, 3D. So to solve for the T here, I would like to use moment. So using moment. So what do we have here? So for this one, Tn, the distance to this point A, so it's Tn times 4 meter. Then how about this 50? So we have to multiply with the distance here. So for this, so let's see what is the direction for this. So this one 90 degrees. So if this one is alpha, so which means this is alpha. So the one that beside alpha is cosine. So which means this one is 50 cosine alpha. And then this one is 50 sine alpha. So the moment from here to this one, so this one is 2 meter. So which means the one on top here, so let's say Tn 4 meter. So T times 4 is equals to, so another directions here that we have, so 50 cosine alpha times 2 meter. So here is 2 meter. So 50 cosine alpha times 2. So the value of cosine alpha we have found, which is 4 over 5. So therefore, T here is 4T equals to 100 times 4 over 5. So which is 100 times 4 over 5. So here is 80. So T is equals to 20. So this is for part A. Okay, next. So given that we are asked to find the coefficients of the frictions between the rod with the ground. Okay, so which means here, the rod is here, so which means with the R here. So the rod might sliding this way, so which means here we have the frictions, so which is mu R. Okay, then after that, look at this Tn here. So this Tn, I will derive into 2 directions. So here, directions here, and the directions here. So because this one is alpha, so this and this, because they are the horizontal, so they are parallel, so which means this is alpha also. So if this is alpha, means this is alpha. So in this direction, if this is t and this is alpha, the one that beside it is the cosine. So which means t cosine alpha, and for this t sine alpha. So I want to look at the whole system. So for part B, so for the vertical directions, so now let's look at the forces that we have here. We have R. For this one, we have T cosine alpha, and then we have 50 Newton. So we just look at the vertical forces that involve. So they must be equal. So therefore, R plus T cosine alpha is equals to 50. So here I form equations. So this is for the vertical directions. Now how about the horizontal directions? So for the horizontal directions, you look at the diagram here. So here we have the resistance mu R, and here we have T sine alpha. So that's it. So these are the horizontal forces that we have. So which means mu r is equals to T sine alpha. Okay, so now what we are going to do here is we substitute whatever information that we have. So from part A, we already know that T is 20. So T can be replaced as 20. And then the sine and cosine alpha, sine is 3/5, cosine is 4/5. So therefore, R, T is 20, cosine alpha 4/5 equals to 50. So R plus 20 times 4/5. So here we have 16 equals to 50. So which means R is equals to 34. Now come to these equations here. So we have found that R is 34 and T is 20. Sine alpha 3/5. So which means mu 34, T is 20, and sine alpha is 3/5. So which means mu is equals to 20 times 3/5. So here we have 12 over 34. So simplify this, 12 divided by 34, 6/17. So which means mu is equals to 6/17. So here is our answer for mu. Happy. Okay, next. Let's proceed to next questions. 6. Two particles P and Q are moving in the opposite directions along a straight line, and then they will meet directly, collide directly. The mass P is Km, and then the mass Q is M. Immediately after the collisions, so the speed P is X, the speed Q is Y. So this is before. Then after, P and Q moving in the same directions, where P is V and Q is 2V. The coefficient of the restitutions between P and Q is 1/5. Okay, so this one is the difference of the velocity. So for this one is after, the difference between the velocity after, and this is before. So the difference of velocity. Okay, so the magnitude of the impulse received by Q is 5 MV. So part A, we are asked to find y in terms of v, x in terms of v, value of k. Okay, so now how are we going to do this? So first of all, similarly, I will try to represent all the informations by using diagram. So one is before, another one is after. So before, after. So P, Q. Okay, so let's just copy this diagram here. So before, after. Okay, so now I'll try to write all the informations in the diagram now. So first of all, we are told that the mass of P is Km, the mass of Q is M, so which means this one is Km, this is M, this is Km, and then this is M. And then what else? Before, the speed of P is X, the speed of Q is Y, so and they are moving in the opposite directions. So P is X, so here. So for this one, this is X, meter per second. And then for this one is Y, meter per second. Okay, then after that, so they're moving in the same directions. Speed of P is V, speed of Q is 2V. So this one is V, and then this one is 2. So basically, yes, these are all the informations that we have. So now let's look at the differences of the speed of the velocity. So the difference of the velocity. So x minus negative y, so it's x plus y. Okay, then for this one, the difference of the velocities. So for this one is 2v minus v, so which is v. Okay, so this one is for these informations that we might use later. Okay, the coefficient of restitutions between P and Q. Okay, now let's see what informations that we have here. Okay, so now we are told that the impulse, so maybe I use different color to show different informations. The impulse received by Q is 5 MV. So now let's see here. So how do I find the impulse for Q? So for Q, so the impulse is equals to 5 MV. Okay, so now impulse means the difference, the changes in the momentum. So I take the later minus the before. So for this one, the momentum is m2v. And then for this one, this negative y means the velocity is negative y. So which means the momentum here is m negative y. So I will take this minus this. Okay, so which means the impulse. So for Q, m times 2v minus m times negative y equals to 5 mv. Okay, the reason why negative y because y is in the opposite directions. We assume that this direction is positive here. So therefore, this one, the velocity is negative y. Okay, then simplify this. So here I have this 2 mv plus my equals to 5 mv. So which means my is equals to 3 mv. So y is equals to 3v. So here I have the answer for the first part. So this is for the first part. Okay, now let's see what other informations that we are given for these questions here. So we have this. So before, after, the difference of the velocity. So which means, so for this, the coefficient of the restitutions is equals to 1 over 5. Okay, so now let's see. So I have to take after. So the after is v, and then the before is x plus y. So equals to 1 over 5. So here we have found that y is 3v. So y is 3v. So which means from here we can just cross multiply and replace y as 3v. So here I have this, okay, I cross multiply first. So which means 5v is equals to x plus y. So where y I can replace by 3v. So 5v equals to x plus 3v. So what does it mean here? It means that x is equals to 2v. So this is the answer for second part. Now, how would we find the value of k? So what other concept that we can apply for these questions? the momentum before, after, they must be equal. So let's see for the third one. So we use momentum. So before and after. So for the after, NV, so which is Kn times V, and then plus for the Q is N to V equals to, now before, so for P is KNX, and then for the Q is N negative 1. So which means here we have this KNV plus 2NV equals to KNX minus NY. So in part 1 and part 2, we have found that the Y and the X. So Y is 3V, X is 2V. So which means here I have this KNV plus 2NV, Kn, X is 2V, and then minus N, Y is 3V. So which means KNV plus 2NV equals to 2KNV minus 3NV. So I will try to put all the K together. So which means I will put this one over to the left, to the right, and then this one I will move over to the right. So which means here, this I will move over to the left, and this one I will move over to the right. So which means 2NV plus 3NV is equals to 2KNV minus KNV. So here I have this 5NV equals to KNV. So this NV and V, they are same, so which means can cancel off. So what does it mean here? It means that the K is equals to 5. So this is for part A. Okay, so now let's see for B. Okay, not enough space here. So B, we need to find in terms of M and D the total kinetic energy loss in this system here. So now let me copy this whole thing. The second page, so that we do not need to flip here and there. Okay, so just leave it like this. Now for second part B. So how do I find the kinetic energy loss? So I will take before minus after, because loss means initial before you have more. So which means the total kinetic energy loss. So for B, the total, okay, instead of write long like that, so I write before and after, calculate first. So before, the kinetic energy that we have, so is 1 over 2 mv squared, so 1 over 2, K is 5, right? So which means 1 over 2 Km. So for P, 1 over 2 Km, the mass is Km. So the D is X, so Km X squared, plus 1 over 2, for Q, the mass is M, the speed is Y, so my squared. So for this one, we have found that the M is 5, so which means 1 over 2, 5M. And then the X, we have found that is 2V. And then plus 1 over 2M. The Y is 3V. So 3V squared. So for this one, just calculate. So 2 squared is 4. 4 times 5 times 1 over 2. So here I have 10. So for this one is 10 mv squared. And then for this one, 3 squared is 9. So it's 9 over 2 mv squared. So which means 10 plus 4.5, 14.5. So this is before. Okay, then after. So let's see what is the kinetic energy that we have for after. So 1 over 2 kn. Okay, so the velocity of p is v. So which means v squared. And then plus 1 over 2, the mass for q is m. The velocity is 2v. So for this one, it's equals to 1 over 2, m is 5, v squared, and then plus 1 over 2, 4v squared. Okay, so simplify this. So here I have this 5 over 2 mv squared plus 2 mv squared. 2.5 plus 2 is 4.5. Okay, so now, so the total loss, kinetic energy, will be equals to 14.5 minus 14.5 mv squared minus 4.5 mv squared. So which is equals to 10 mv squared. So this is for part B. So this is the whole process. So now proceed to question 7. Okay, let's start question 7. We are given the diagram. So it's formed by 3 different shapes. So PQUV, uniform square, length 3A, URST, uniform square, length 6A, QRU, uniform triangle, where UQ is 3A, UR 6A, and then the angle QUR is 90 degrees. So the mass per area is K for this PQUV. So URST same is K, the mass per unit area. The mass per unit area for QRU is 2K. So the distance of the center of mass of the template from QT is D. So QT is here. So we are asked to show that D is 29 over 14A. So now what am I going to do for the first thing here is, so I will make the plane to XY axis. So I will call this one as Y axis. And then this one as X axis. So let's say this is Y axis, and then this is X axis. And then this one will be the origin, so okay, so where is the center of mass of each of this shape here? So the center of mass, so for this one, it will be at the center because it's uniform. So 3A, 3A, so which means for this one, the center here is negative 1.5A, 1.5A. Okay, then for this one, let's say the center of mass is here. So for this one is 3A and negative 3A. So negative because it's below the x-axis. So 6A half is 3A. For this one, negative here is because it's on the left side of y-axis. So 3A half is 1.5A. So therefore it's negative 1.5A here. Now, we need to find the center of mass for the triangle. So we need to find the centroid here. So how am I going to find the centroid? Where is the positions? So for this one, so the centroid, the definition is half. So from this vertex, you go to the center of this side. And then same thing. From this vertex, you go to the center of this side. Okay, so now what am I going to do here is I try to find the coordinate of this point, which is the point of intersections of these two lines here. So how do I find the point of intersections? So here, I will call this one as line 1, and then this one as line 2. So look at this line 1. So line 1, the gradient is equals to, so the gradient here is 3a, and then here is also 3a. And then it's going down, so the gradient is negative. So I just use a simple rise over run. So for this one is negative. The rise is 3a, and then the run is also 3a, so which is negative 1. And then the intercept is here, the y-intercept, which is 3a. So the equations for line 1 will be y equals to mx plus c, so negative x plus 3a. Okay, now for line 2, so line 2 is this. So where the rise is 1.5a and the run is 6a. So similarly, the line is going down, so the gradient is negative. So therefore, n is equals to negative 1.5a over 6a. So 1.5 over 6. So 1 over 4. So the gradient is negative 1 over 4. So for this one is the y-intercept. So C. So the y-intercept for line 2 is 1.5a. So 1.5a. So the equations is y is equals to negative 1 over 4x plus 1.5a. So I try to solve simultaneous equations to find the center. So first equation equals to second equations. So therefore I have this negative x, so negative 1 over 4x plus 1.5a equals to negative x plus 3a. So which means 5 over 4x is equals to 1.5a. So the x is equals to 1.5 times 4 over 5. So which is 1.5 times 4 over 5. So here I have 6 over 5. Okay, sorry, there is a small mistake here. So minus x, I bring over here become plus x. So minus 1 over 4x plus x is 3 over 4 instead. So sorry for this. So this is 3 over 4. So which means 4 over 3 here. So 1.5 times 4 over 3. So 1.5 times 4 over 3. So it's 2. So x is 2a. Okay, then substitute into the first equations. So to find the y coordinate, so y is equals to minus 2a plus 3a. So which is a. So this will be my center of mass for the triangle. So this coordinates here is 2a. Okay, so now to find the d. So what am I going to do here is for a. So for the square PQUV, so what is the area for PQUV? So PQUV is here. So it's a square by 3a, 3a. So which means the area is 3a times 3a. So which is 9a squared. Okay, we are told that the mass per unit area PQUV is k. So which means 1 unit square is k. So we have 9a squared. So the mass is equals to 9a squared times k. Okay, now look at another one, the square. So QRST. So the area. So for QRST, where's QRST? Okay, sorry, URST. I copy wrong. URST. So URST is here. So it's a square where 6a, the other length. So which means 6a times 6a. so which is 36a squared. So the mass will be 36a squared k. So now for the triangle, QRU. So what is the area? Half. So for this triangle here, this is 3a, this is 6a. So just simply half times base times height. So 1/2 times 6a times 3a. So which is 9a squared. How about the mass? So for the triangle, so the mass per unit square is 2k. So which means we take 9a squared times 2k. So which is 18a squared k. So this is the mass for different shape here. So here, let's find the center of mass. So the total mass is 9a squared k plus 36a squared k plus 18a squared k. So for this one is 9 plus 36 plus 18. So here we have 63a squared k. Okay, so now let's proceed to the next part. So what am I going to do here is I want to find the center of mass of the whole diagram, of the whole figure. So which means 63a squared k. So I don't know where is it. I want to find it. So I just put the coordinate as xy. Then equals to. So now for each of this, PQUV, the center is negative 1.5a, 1.5a. So for this one is negative 1.5a, 1.5a. And then URST, the center we have discussed just now, which is 3a, negative 3a. So this is 3a, negative 3a. And then for the triangle, we also found that is 2a. So for this one, the center is 2a. So what we need to do here is we take the mass, multiply the coordinates. So in the vector form, so which means for this one is 9a squared k times negative 1.5 a times 1.5a, and then plus. So the space is a bit too small here. So let's add another picture. Okay, so I just copy this whole thing here. Okay, then 36a squared k. So 36a squared k, the coordinate of the center, 3a, negative 3a. Okay, then lastly, the triangle, 18a squared k, the center of mass, 2a. So here I form the equations. So what am I going to do is I just do separately the top and the bottom. So here I have this. If I look at the x component, so which is 63 a squared kx equals to, okay, 9 times 1.5. So 9 times 1.5. Okay, decimal easy to count. 13.5. So which means it's negative 13.5 a power 3k, and then plus 36 times 3, 108. So it's 108 a power 3k, and plus 18 times 2, 36 a power 3k. So I take the top component, multiply with this. Okay, now I try to find the value of x here. So which means 63a squared k x is equals to So for this one is negative 15.5. So negative 15.5, 13.5, sorry, and then plus 108, and then plus 36. So here I have this 130.5. So here 130.5, a power 3k. So to find x, 130.5, a power 3k divided by 63, a squared k. So what do I get here? X is equals to 130.5 divided by 63. So here I have 29 over 4, or 29 over 14. So 29 over 14, 8. So that's the distance from QT. So QT, so the distance here. So which the question asks us to prove here. Sure. So at the same time, we can also find what is the y coordinate for the center of mass. So which means 63 a squared k y equals to, so 9 times 1.5, so it's 13.5. So 13.5 a power 3k, and then plus minus 36 times negative 3 is 108 a power 3k, and then 18 a power 3k. So for the y component, I will just do the calculation for all this. Multiply with this. Okay, so 63 a squared ky equals to, so here I have these calculations, 13.5 minus 108 plus 18. So here I have this negative 76.5. So negative 76.5 a power 3k. So which means to find the y, so negative 76.5 a power 3k divided by 63 a squared k. So what is y? So 76.5 divided by 63. So here I have this negative 17 over 14. So this is the y coordinate for the center. Okay, so done for part A. Now, part B. So we are told that the object is freely suspended from the point Q and hang where this QR at theta degree to downwards of the vertical. We are asked to find the angle here. So what am I going to do? So maybe I will need to copy this diagram here. Okay, it's okay. So never mind. I just, yeah, so it's better to copy the diagram. So for B, so here we have the diagram. Now we have found that the center is here. So let's see the center. I use purple color. So the x is this, and then the y is this. So this is the center of mass for the whole thing. So 29 over 14. So let's say 29 over 14 somewhere here. Then this is this. So this is 29 over 14a. And then negative 17 over 14. So we hang this object at point Q freely. So which means it will directly go to the center of mass. So this is how it will look like. Okay. So now what we need to find here is the angle that made, so QR at theta degree to the downwards vertical. So this is the downward vertical, and then QR is here. So we need to find this angle. So how do we find this angle? So we call it as theta. So this angle is theta. QR is here. The angle is theta. Right now, how am I going to find? So first of all, I can find this angle and then I minus this angle. So the whole thing here minus this, then I will get this. Okay, so one by one. Now let's find this angle here. So this angle, let's say I call it as theta 1. So now what do I see here is I have a right angle triangle. So for this theta 1, I know that here is 6a and then here is 3a. So I can just use simple trigonometry ratios where this is the opposite sides and this is the adjacent side, tangent, to find this angle here. So tangent theta 1 is equals to 6a over 3a. So which means this theta 1 is equals to arctangent 2. So this is 2. Okay, then next, I will try to find this angle here. So I call it as theta 2. Now, how am I going to find this angle? So here, I know that it passes through the center of mass here. So I try to form a right angle triangle. Okay, so now, this is 3a. And then for this one is negative 17 over 14a. So the whole thing here is 3a plus with this. And then the vertical line here is 29 over 14a. So maybe I just redraw the diagram so that we can see it clearly. So 90 degree. So this is the second angle that I need to find. So for the vertical line here is 3a plus 17 over 14a. So which is 3 plus 17 over 14, 59 over 14. Okay, then for the horizontal line here is 29 over 14a. So similarly, opposite sides, and then this one is the adjacent side. So I can use tangent for this. So tangent of this second angle, 29 over 14a divided by 59 over 14a. So which means is 29 over 59. Okay, so now to find the angle, so arctangent 29 over 59. So as discussed, to find this angle, I take the first angle minus the second angle. So which means theta will be, the first angle is arctangent 2 minus the second angle is arctangent 29 over 59. So which means this one is equals to. Now I try to evaluate this, make sure the calculator is in. So what's the answer to the questions one? Degree. So do you see this? Degree, yeah? So make sure that your calculator is in degree mode. So this one is R. R means radian mode. So I have to change to degree mode. Shift setup. So angle unit degree 1. Okay, so now I just need to use the calculator, rely on the calculator, arctangent 2, and then minus arctangent 29 over 59. Okay, let's see what do we get here. 37.3. Round off to one decimal place. So it's 37.3 degree. So that's it for the second part, B. So maybe I go back here. So this is the questions and the solutions for A and B. Okay, so now proceed to question 8. Okay, let's look at question 8. This will be the last questions. Yes. Okay, so now we have this diagram here, all information shown. So incline, angle, tangent is 1 over 6. So here is the angle. Now, look at the information given here. So the meaning tangent 1 over 6. So which means if I have a triangle, right angle, and then this is alpha. So tangent 1 over 6 means this is 1 and then this is 6. So by using Pythagoras theorem, we can find this is square root of 37. So which means from here I can tell that sine of this angle is equals to 1 over square root of 37. And then cosine of this angle is 6 over square root of 37. So I just prepare this. Later we will going to use it. Okay, now point A on the ground, bottom, and B on the top. So AB greatest slope, and then AB the length is 4 meter, so which means AB 4 meter. Okay, the particle P of mass 3 kg. So we have the particle at this point A here. So P 3 kg, 3 kilogram, is projected with the speed u. So which means projected by the speed u. So u ms 1 from A directly towards B. So the coefficient of the frictions between the particle and the ramp is 3 over 4. So here mu is 3 over 4. So here 3 over 4 coefficients of the frictions. So we are asked to find the work done against the frictions as P move towards A to B. Okay, so now what am I going to do here is I will try to draw whatever information is needed here. So I extend the line. So now look at the forces that we have. So for this one, let's choose here. So this one is mg. M is 3, so 3 gravity. So what I will do is I will derive this into 2 directions. So one is perpendicular to this, and then another one is in these directions. Wait, so now let's look at the angle here. Because this one is 90 degree, so this one will be 90 minus alpha. And then here we have this one is 90 degree, so which means this will be alpha. So this force is beside the alpha, so which means we are using the cosine here. So this one is 3g. So for this one, 3g cosine alpha. And then this one will be 3g sine alpha. Okay, now let's see what other forces that we have. So we have R here. Okay, because the object is moving upwards, so which means the resistance will be here, the frictions, so which means the frictions is here. So the diagram is a bit crowded. Okay, so let's see what I can do here. So here, this one will be mu r, where mu is given 3 over 4. Wait, so now let's find the value of r here. So for A, okay, so because r and this one they are equal, so which means r is equal to this. So r is equals to 3g cosine alpha. So g is 9.8, so 3 times 9.8, Then what is cosine alpha? So cosine alpha I have determined, which is 6 over square root of 37. So 6 over square root of 37. So for this one is equals to, so I just calculate, what do I have? So 3 times 9.8 times 6 divided by square root of 37. So here I have this 29. So 29, because there are so many minus, so 29.0. So here we have the R, and then what is the mu R? So the resistance mu R, so the mu is 304, and then R is 29. So which means 304 times 29. So here I have this 21.75. So this one will be the frictions as P moving from A to B. So to calculate the work done, so work done, we take the force multiply the distance. Okay, so which means for this, so the work done is equals to the force multiplied with the distance. So which means 21.75, sorry, I copy wrongly, 21.75, so 21.75, and then the distance is 4 meter, so therefore 21.5 times 4, so here I have 87 joule. So this is for part A. Now, given that the instant P reached the point B, the speed is 5. So at point B, so when the particle is here, 5 ms negative 1. Okay, then we are asked to find the value of U by using the work energy principle. Okay, so now what am I going to do here? So I need to find the energy, so for B. So let's see at point A. So what is the energy that we have here? So at point A, so we just consider the kinematic energy, so which is 1 over 2 mv squared. So at point A is 1 over 2, n is 3, and then the velocity, the speed is u squared. So which means for this one is 1.5 u squared. Now let's see what happened at point B here. So at point B, we have the kinetic energy, and then we also have the potential energy. So this one mgh. So now what is the h here? So this one is alpha, and then this is 4. Opposite over hypotenuse is sine of this. So which means the distance here will be 4 sine alpha. So what is sine alpha? Sine alpha is 1 over square root of 37. So which means the distance here is 4 over square root of 37 meter. So at point B, so we have the kinetic energy. So 1 over 2, 3. So the speed is 5. So 1 over 3, 5 squared. And then plus with the potential energy. So mgh, so which is 3. Gravity is 9.8. And then the height, 4 over square root of 37. So let's calculate this. So 1 over 2 times 3 times 5 squared, which is 25, and then plus 3 times 9.8 times 4 divided by square root of 37. So here I have this 56.83332091. Okay, so this is at point B. So suppose the energy, they are supposed to be the same, but because some of them has been worked against the frictions. Okay, so which means they are not equal. So the initial will have more energy than the later. So the difference is used for the frictions. So which means this minus this will get this. So here I form the equations 1.5 u squared minus 56.83332091 is equals to 87. So which means u squared 1.5 u squared is equals to this number plus 87. So here 143.83332009. So u squared is equals to, so 1.5 bring over there become divide, so divide 1.5. So here I have this 95.8888. So 95.888. How many 8 there? So basically there are 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, and then 0, 6. So the u is equals to square root of this. So square of this number 9.79. So here I have this 9.79. So here I found my u. Okay, so here we solve for the b. Value of u is 9.79, round off to 2 decimal places. Okay, so now next, the particle leave the ramp at B and move freely under the gravity until it hits the ground at point C. So we are asked to find the horizontal distance from B to C. So how are we going to do this? So now let's see here. So maybe I just redraw the diagram a little bit. So here I have this. So the particle is here, and the speed is 5 ms-1, and this is alpha. So we also know that sine alpha is 1 over square of 37. So sine alpha is 1 over square of 37, and cosine alpha is 6 over square root of 37. So it moves freely. So which means the particle will just like this. It's a projectile motions. So here we want to find at where it will hit the ground. So we call it as point C. Right, so now what we have to do here is, so we derive this into 2 directions. So the vertical directions and the horizontal directions. So for this one is alpha. So this one and this one, they are parallel. So this is alpha 2. So the one that beside the alpha is cosine. So which means for this one is 5 cosine alpha ms-1. And then for the vertical is 5 sine alpha ms-1. So this is the speed. So we derive the speed in 2 directions. So now let's look at this. And the distance here, we also found that. So the distance is 4 over square root of 37. So 4 over square root of 37 meter. Alright, so now, how are we going to solve projectile motions problem? So if I look at the vertical directions, so this one will be the initial velocity, and then we have the gravity g, so which is the accelerations. So which formula should I use? So I will use the formula v is equal to, s. So I'm going to use the formula s is equal to ut plus 1 over 2 at squared. Okay, so this is a formula that I'm going to use here. So for the vertical directions, so the initial velocity is 5 sine alpha, so which means s is equals to 5 sine alpha t, and then plus 1 over 2. Now, if I assume that this direction is positive, so which means the gravity will be negative g. So negative g t squared. Okay, now it depends on how do you define the distance, the displacement. If let's say, if I define the displacement here is 0, so which means initially it already have some displacement here, so which is 4 over square root of 37. So which means, so the initial positions is 4 over square root of 37. So this is the vertical directions for 1. So this is a formula that I'm going to use. Now what I want to solve here is when it hit the ground. So when it hit the ground, the Sy will equal to 0. So at this point, the Sy is equal to 4 over square root of 37. So which means when Sy is equal to 0, when it hit the ground. So Sy is equal to 0. So what do I have here? So 0 is equal to 5. Sine alpha is 1 over square root of 37. Okay, and then t, and then minus 1 over 2, g is 9.8, t squared, and then plus 4 over square root of 37. So basically, I have a quadratic equations. So for this, I'll just bring everything over to the right side, so easier because I prefer the coefficient of t squared is positive. So for this one, 1 over 2 times 9.8, so 1 over 2, so 0.5 times 9.8. So here I have 49 over 10, so which is 4.9. So which means 4.9 t squared. Okay, then for this one, I bring over to the left, it becomes minus. So minus 5 over square root of 37 t. Okay, then this I bring over to the left, become minus 4 over square root of 37 equals to 0. Wait, so for these quadratic equations, no matter how you simplify it, it still look very complicated because the number they are not very nice. Now, what am I going to do is because I don't like to see so many fractions there. So when we apply the formula, it will be very difficult for us to write and to calculate. So since the denominator, they are all the same, so I will just multiply the whole equation by square root of 37, although it might not necessary, but I just don't like to see so many fractions there. So which means for the first one, 4.9 square root of 37 t squared minus 5t minus 4 equals to 0. So here I have a quadratic equations in terms of t. So how do I solve quadratic equations? So just simply apply quadratic formula. So t is equals to negative b plus minus square root of b squared minus 4, a is 4.9 square root of 37, and then c divided by 2a. So 4.9 square root of 37. So how am I going to calculate this? So of course, rely on the calculator. So you can just press the quadratic formula into your calculator, or you can use the special functions in your calculator here. So go to the setup, so your calculator can solve equations. So equations here. So polynomial quadratic, so degree 2. So what is the coefficient of x squared? So for this case is 4.9 times square root of 37. Now for coefficient of x is negative 5, so negative 5. And then the constant is negative 4. So here I have the first value. So t is equals to 0.459694, or t is equals to, so for the second one, negative 0.291940. So I write more decimal places. So which means the negative t we have to reject. So we only accept the t that is positive. So this is not the final answer. So therefore I leave more decimal places to make sure that the accuracy is there. Now you can always double check. So for this one, if I use the quadratic formula, so negative of negative 5 and then plus square root of b squared, so it's negative 5 squared, minus 4ac. A is 4.9 times square root of 37. So this is the A. And then C is negative 5. C is negative 4. Okay, then after that, divide by 2A. So A is 4.9 times square root of 37. So you can also use the quadratic formula. Okay, let's see what you get. So the answer is 0.459694. So it's the same. So now if you want to get a negative 1, so what you do is you just go to your cursor and then you just change the plus to become minus. So here you have another answer here, negative 0.291940. So of course, use the function in the calculator, you will get the answer faster rather than spending time pressing one by one. So now look at the horizontal directions. In this projectile motions. So for the horizontal distance, so Sx will be equals to, so the initial velocity is 5 cosine alpha, so which is 5 cosine alpha, and then times t, then plus 1 over 2 at squared. So for this horizontal, we don't have any forces. So there's no wind, no frictions or whatever, because it's freely. So there is no accelerations. So these portions will be 0. So let's see here. The t is equals to, so we want to know when it hit the ground. So the t is 0.459 and then 694. So which means the horizontal distance Sx will be equals to 5. So what is cosine alpha? 6 over square root of 37. And then the t, I just substitute 0.459694. Okay, so just rely on the calculator for the calculation. So 5 times 6 divided by square root of 37. And then multiply 0.459694. So here we have this 2.267196.842. Round off to 3 SF for the final answer. So which means 2.27. So it's 2.27 meter. So let me answer the questions. So the horizontal distance B to C. So B to C, horizontal distance is referring to this part. So yes, we have found it. So that's it for part 3. So I'll let you see the questions one more time. So this is the whole questions. So for part A, we are asked to find the R. R is 29, and then we want to find the work done, so 87 joule. And then part B, the U is 9.79. And then for part C, so I forgot to mark. So for part C, the horizontal distance of B and C is 2.27 meter. So this is the last questions. Okay, so please remember to hit the subscribe button. Thank you very much. See you. Bye bye.